Risk Management in the Preparation of Poultry Products, by Oscar Rodriguez Gonzalez. This presentation was divided in 4 sections: food materials, human factor, machines, and operations environment. Before exploring deeper the management of risks, we reviewed some trends that are leading the management of food operations. From an engineering perspective, one of big trends has been to automate, because production can be more cost-effective and predictable. A complement to the automation of repetitive tasks is the collection of the information generated by the machines. This process is being facilitated by the ability to connect machines to the internet and transfer information. From a policy perspective, reducing the risks associated to consumer harm has been facilitated by establishing the best practices for each sector. These practices have become regulations or private standards with specific sets of requirements that vary depending on the designer. Best or good practices can be arranged in different designs, but the idea is to reduce the number of emergencies, and focus on preventative measures. Also, additional motivations for causing failures are being discovered, and the principles of the hazard analysis and critical control points plan being adapted. For food industry experts, threats means terrorism-motivated contamination, and vulnerabilities means economically motivated adulteration. The term risk is usually perceived as negative, but anything considered risk can be transformed to opportunity. The general idea that managing risks is about reducing the uncertainty of achieving the business objectives is becoming globally accepted. For any business to exist, the first objective is to be profitable. Once this is achieved, additional emphasis can be placed in reducing the harm to its customers and its community. The various risks can be managed more efficiently and effectively utilizing systems like the hazard analysis and critical control points plan. This type of systems identifies control measures for each category of hazards at each step of the process. The management of the risks can be enhanced by utilizing metrics like risks priority numbers to define priorities, and target hazard levels, which are called food safety objectives. Systems like the hazard analysis and critical control plans have facilitated the migration from following the industry practices to establishing a system that improves cyclically the management of risks. Hazard analysis and critical control plans have also facilitated prioritization in risk management by defining which controls are critical. Critical control points were initially defined as those that prevent the presence, prevent the increase, or reduce the hazard. Some tolerance could be given if the hazard is going to be reduced in a subsequent step. When talking about managing food materials, it is known that the level of risk also depends on the type of food material. Typically, raw materials are considered more risky than processed materials, but this can vary depending on the growing and the handling conditions. It is also known that controlled environments are more predictable than open environments. Food-related hazards can also be grouped to facilitate its management. Physical hazards can be grouped by the chemical composition of the material, biological by the type of organism, and chemical based on the environment where they can be found. This grouping can be also based on the principle of their detection and control methods. A key component of managing materials is traceability. Tracking the movement of materials facilitates the recall of defective products. This accounting-like component of management systems is advancing with the adoption of new technologies like blockchain. Blockchain facilitates the transfer of assets between various parties, and therefore assists with tracing on real time. Additionally to transferring assets, we also transfer information about the thing. Information about the material can be found in labels at retail or in specifications during processing and handling, and product descriptions in hazard analysis and critical control plans. The section about food materials was complemented with a traceability exercise. Material balances were created based on production and handling reports. This included finding some glitches in the documentation system. The second section was about humans, which are used extensively in the preparation of food materials. The risk of contamination by humans can be analyzed logically, like is done with food equipment. Contamination can occur from the secretions that we generate continuously, or by transferring contaminants between areas with our limbs. Contamination with bodily fluids can be prevented with protective clothing. The level of protection will depend on the location related to the food material, and surfaces that can cause cross-contamination. To maintain human bodies clean, sanitary facilities can be provided to clean and sanitize. Protective equipment can be provided to contain the body and its secretions, and it can be disposable or reusable. These facilities and clothing require frequent maintenance, which can be done in-house or by contractors. The complex issue with humans is that we have our own set of beliefs and make decisions as individuals. Therefore, compliance with sanitary and other personnel practices can be implemented utilizing reward and punishment systems, or utilizing models for influencing behavior. Food safety culture is one big concept being studied scientifically and evaluated by industry actors. Another important aspect of managing humans in the operations environment is communication. Internally, tasks are communicated and verified between leadership, supervisors, and operators. Operators also coordinate tasks between them. Therefore, managing internal communication effectively is key for running operations smoothly. Information also flows externally with consumers and the various actors of the supply chain. This information includes product data and consumer and regulatory demands. This information can be managed more easily by locating it in documented management systems. These documents can serve as reference to operators and analyzed periodically by management for improvement. The human factor section was complemented with exercises for transferring information between various people, and between a director and its assistant. The idea was to understand how messages get twisted if not communicated properly. Before talking about equipment, we need to review the concept of flow of materials. When we prepare a flow diagram in the hazard analysis and critical control plans, we define the steps of the process. Generally, the steps are related to an operation, like receiving or cooking, and it may include a series of tasks to be completed in addition to the machine completing the work it was designed to do. The various steps or activities can be organized to optimize the use of space, and to better control of the operation environment. The number of humans is reduced this way, but personnel can advance from being a human repeating tasks to being a controller of the operation and conductor of cleaning, maintenance, and repair activities. Operations identified as critical for food safety, or quality, require specialized monitoring. Courses that study of this type of operations are called Better Process Control School. The conditions for conducting these operations are studied scientifically and are generally categorized as thermal or non-thermal. The study of the arrangement and combination of control measures for microbial control has been called hurdle technology. The study of the control of these operations utilize the principles of metrology and statistical process control used by quality engineers. When the conditions for operation are defined, parameters, upper and lower limits are established, and the operation adjusted if out of range. The repetitive task of monitoring a critical control point can also be automated. The selection of control measures can be different depending on the hazard analysis and critical control points team and the process being analyzed. A review of the USAPEEC plan models designed for poultry products indicate that experts suggest antimicrobial treatments as critical control points at slaughtering, and microbial preservation treatments, cold temperature, at downstream processes. Additional critical controls can be added using supplier documentation and visual inspection as control measure. Downstream processes also include antimicrobial operations as critical control points. Examples of these treatments include thermal processing, acidification, and irradiation. Poultry products are typically combined with other food material. In some cases the treatment has to be designed for the plate combined or the ingredients separately. A critical aspect of preventing an increase in the hazard levels in a food material is cleaning and sanitation. Sanitation is generally defined as an antimicrobial treatment to the equipment or food contact surface. The study of sanitation includes understanding the levels of disassembly required by each tool or equipment and the method for decontaminating it effectively and efficiently. The results of sanitation operations also need to be verified on real time to account for day-to-day variability. Some tolerance can be given based on the potential of contamination of the zone being treated. A complement to the standard operating procedures for critical control points, CCP/SOP, are the procedures for cleaning and sanitation, which are called Sanitation Standard Operating Procedures, SSOP. Like most of the SOPs, SSOPs contain the elements of a circumstance, where, who, when, and how. An addition to cleaning and sanitation plans is maintenance. Maintenance generally focus on reliability, reduction of failures, but there is a concern that these failures can contaminate the food material. The real importance of maintenance is to focus on steering downtime, or production time losses, and is evolving from reactive to preventive to predictive. The challenge is to avoid the problem before it occurs in a cost-effective way. The section dedicated to equipment was complemented with an exercise of creating a cleaning and sanitation plan. Various tools and equipment were analyzed, and the conditions for their cleaning and sanitation defined. The fourth section focused on the operations environment. The building can be considered as the large container where the operations occur. The ideal is to have a controlled environment, and it can be divided to better manage the microenvironments. A complement to separating the activities internally is analyzing the various types of flows that occur. The most important flow occurring in a food processing environment is of materials, products, and wastes. Most of the food processing operations are designed to receive dirty materials and prepare clean products. In addition to food materials, there are support materials like water and air. The problem with these materials is that they are also carriers of hazards like microbes, spores, or chemicals. When these materials are used for removing hazards, they should flow from clean to dirty to make cleaning operations more efficient. Humans are also carriers of hazards, and flow between the various areas. Therefore, in addition to protective equipment, controlling the flow of personnel can reduce the potential of cross-contamination. And there is wildlife in the exterior. Wildlife is double trouble, because they cause material losses and contaminate the environment. Its access to the facility can be controlled using a diversity of methods, and is typically conducted by specialized contractors. One of the accepted practices to prevent cross-contamination between areas is to use color to differentiate cleaning tools. The level of sanitation and monitoring of these tools also depends on the area being used. And a similar approach for improving the maintenance of buildings can be implemented. The goal can be to minimize the occurrence of emergency repairs, and focus more on preventive and predictable tasks. The section on operating environment was complemented with an exercise of placing building maintenance accessories in single or multiple buildings facility for a process like deboning or meal preparation. Thanks to USAPEEC for sponsoring this event.